watch the clock, and watch the timer. All right, did you watch it? If you were watching closely, you may have seen, and of course you can rewind and go back and watch it again, you may have seen that the time on the display of this NuTone IM4006 advanced 1 minute about 3 to 4 seconds before the timer did. And these have been running side by side for the last 24 hours, 42 minutes, and 30 seconds. Why are we doing this? Well, this 4006 was sent in by a customer. It had all of the typical 4006 age-related problems. It was humming, it was buzzing, the radio reception was really bad, the intercom barely worked. It was just basically old and tired. So I did the normal rebuild on it, and everything on it works great now. When we called the customer to tell him it was done, he mentioned that he forgot to mention that he had a problem with the clock. He said from the very first day it was installed new in like 1989, the clock never kept good time. And I asked him, well, how much did it gain or lose like in a week's time? And he said, well, as near as he could remember, it gained probably 3 minutes a week, which is a whole lot. And the thing about these are, this is a quartz controlled clock module. On the clock, the display slash memory board. And on that board is a specialized integrated circuit that controls all of the functions for the clock, the display, the tuning, the memory for radio stations, set the clock, all of these things. And that integrated circuit has a quartz crystal that feeds a 4.5 megahertz pulse into the integrated circuit to create the clock for the integrated circuit. Since this came up after the repair was done, I told him I would have to put it back on the workbench and take a look at it and see, because this is not a common problem. The only time I've had people complain about the time keeping on NuTone intercoms are sometimes with the retired Navy guys, because Navy guys oftentimes have this thing about time and clocks, because time is important when you're navigating in the middle of the ocean. And I assume this is before GPS was invented, because if you don't know what time it is precisely, you don't know where you are, and that could be a problem. Anyway, this fella is not a retired Navy guy. So I told him, well, I would check it out and see. So I set it back up, and in the service manual for this, for IM4006, there is a page that explains how you can adjust the timing signal for the clock. However, the information on that page apparently is incorrect, because in following it, it did not turn out the way it was supposed to according to the instructions. It says that you attach a very, very, very small value capacitor to one of the leads of the integrated circuit, and you're supposed to measure a certain frequency, which is, I think, is 2.5 megahertz, or maybe it's 20, yeah, I think it's 2.5. I put the manual away. I should look. Hold on. All right, according to the service manual, 4.5 megahertz clock adjustment. Connect a 4 picofarad capacitor, 1 to 10 scope probe, and frequency counter to pin 6 of IC2 on the phase lock loop PC board. Adjust trimmer TC1 so counter displays a reading of 4.5 megahertz plus or minus 15 hertz. It doesn't work that way. So I'm not sure. I think the instructions are wrong. I did some looking around and I could not find a service bulletin where anybody said it was wrong, but following those instructions, there isn't any way you get 4.5 megahertz out of it. And I did set up and test 4 other display assemblies, and they're all the same. So not sure what's up with that exactly. I spent a little bit of time this morning looking over the data sheet for the integrated circuit that controls all of this. It was no help at all. The only thing it showed was that indeed the leads from the crystal do feed into 2 pins on the IC, and across those 2 pins there is a variable capacitor that I assume is there to make adjustments to the signal for accuracy, but it doesn't specify what it is or how it should be set and what you should expect to get out of it. So it's somewhat of a mystery at this point. So I did what any good service center would do in trying to make sure the customer's set will work properly. We did exhaustive 4 days worth of testing on his unit and 2 other 4006s that I have rebuilt recently to compare them side by side to see what is typical for accuracy on one of these units. Now, this is where it gets a little dodgy. His set, on an average, gains about 3 to 4 seconds a day, and that's comparing it to my little OXO3 timer kitchen clock thing, which I use here in the shop all the time. This cost me, when I bought it, I don't know, 20 years ago, probably cost me like 20 bucks. So you get what you pay for. The other 2 4006s are about the same, 3 to 4 seconds they gain over time. And where this becomes complicated is you're measuring this for accuracy with something like this that is probably not any more than, and most likely less accurate than this. So you get this variation between the 2 units because not super accurate, and probably also not super accurate. If this one runs a little fast and this one runs a little slow, you get a much wider variation in timing. Although, and I did look just out of curiosity to see if it's possible to buy a super high accuracy, super high precision counter or timer, and I couldn't actually find one. I did find some test and measure equipment that has that built into it for many thousands of dollars, and I don't really have anything here in the shop that can accomplish that, because why would I? It's not something I normally do. I can't tell the fella that it's 100% accurate, but I can tell him based on the testing that we did, it's probably 100% typical of what a 4006 would be like. Now, why does it run fast or slow? Well, it all depends on how precise the integrated circuit processes the signal from the crystal. It depends on how accurately the crystal was manufactured, because it's supposed to be at 4.5 megahertz. This is a common consumer quality electronic component crystal. This is not the kind of crystal that you put into a spacecraft that you're going to shoot off to Mars with astronauts in it. Okay, it's not a NASA quality crystal. Also, in the world of crystals, because the crystal is actually sort of the heart of the whole system, because it's what sets the initial timing. In more accurate equipment, which I actually have one over there on the workbench over there, more accurate devices will have what's called an oven-controlled oscillator. Crystal is an oscillator, or an oven-controlled crystal. And what that means is inside the device is a little enclosure, usually it's metal, and it'll be packed full of all kinds of really special insulation and a little heating element, and the crystal sits inside the little, wait for it, oven. And the oven is turned on all the time, whether you're using the device or not, and it maintains a specific temperature because the crystal will oscillate at a different frequency based on the temperature that it's at. The other things that can affect the accuracy of a design like this are the overall ambient temperature of the unit itself, because integrated circuits and transistors, they are temperature sensitive to some degree. However, I think that the temperature of the back of the set inside the wall would be fairly consistent if it's on all the time, because it's always running, it's always chewing up a little bit of power, and it's always generating a little bit of its own heat. So I wouldn't imagine that would be the biggest factor. The other thing which I explained to the customer prior to all of this testing was that if the problem seemed more recent, because this unit is 35 years old, and sometimes people don't always remember everything exactly correctly. If the problem with the clock was a more recent problem, like in the last 3 or 4 years, it could also be because of the general degrading of the entire set because of its age, which is the reason it came here in the first place. What I'm going to tell him is we did exhaustive testing, and it seems typical for what a 4006 is like. And if it gains approximately, we're just going to round it off and say it gains 5 seconds a day. 5 seconds a day works out to be approximately 2.5 minutes a month. And what you have to factor into it is, if you're looking at this after 30 days and it was set perfectly correctly. Perfectly correctly is an interesting thing, because if you're setting this based on what your kitchen stove clock says, how accurate is the kitchen stove clock? Because on a digital clock, the numbers only change once every minute. So if you look at the kitchen clock and it says 1:56, is it really just 1:56, or is it really 1:56 and 45 seconds? Because you don't know until it changes. It just changed to 1:57. So at that moment, it was 1:57. Now it's 1:57 plus however many seconds I've been yammering on and on about this. If your reference clock, kitchen stove, is a little ahead from what you think it says, and you set this, you get this variation between the two times, and there may be times that this may be 1:57 and 50 seconds, and it may have gained a minute or two, but the clock on the stove, it might have gained also, or it might have lost because it could lose time just as well. And so you have this wide variation of accuracy between different devices. And that's why in schools, like when I was in elementary school, lots of times, because every classroom has a clock, right? And those are all analog clocks because they have hands and second hands on them that go around. Those are usually part of what's called a master clock system. So in the office, you have the master clock, and the master clock is the one that feeds signals to all of the other clocks in the school. So if you set the master clock for 8 o'clock in the morning, all the other clocks say 8 o'clock in the morning, and every time the master clock ticks forward 1 second, it sends a signal out, and all the other clocks in the school tick forward 1 second also. So they're all synchronized together electrically. There should be no variation other than, I suppose, perhaps the mechanical variations, but they've been making clocks for a long time, so I think they got that worked out. So accuracy between clocks is a thing. How accurate is the clock in an IM4006? I don't know exactly, because there isn't any specification that says what the accuracy should be. So it has to be what seems reasonable and typical. And reasonable and typical seems to be, based on our very small sampling of 3 sets altogether, approximately 3 to 5 seconds a day. Gain, not loss. So I don't know. I thought I'd do a quick video about it because it was an interesting question that I don't really have a clear answer for, but it seems that we'll have to fall back on what is typical. So I hope you found this interesting, and perhaps some of you were able to geek out on this, because this is kind of a geeky topic. If you did, give it a thumbs up, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.